Hello, my name is Don Hummels. I'm chair of electrical and computer engineering. So we have one department, two separate majors, right? The electrical engineering program, a very traditional degree that's been around 150 years or so, could deal with things from very large systems. You think about power generation, power distribution, electric vehicles, and we go smaller and smaller scale. So you might be talking about radars, sonar systems, communication systems, and then down to things that you have trouble seeing, right? Electronics design, the control systems, the algorithms that control all sorts of craft, down to microscopic technologies. We're standing here in the Engineering and Science Research Building where we run our own clean room. It's a research facility where we manufacture devices and sensors that are microns or nanometers in scale. So we do that whole scan, the whole range of devices in our electrical engineering program. Contrast that a little bit with computer engineering, where it's all applications of computer technology to devices that you might use every day. We're in a research facility here. This is the Engineering and Science Research Building. We work with the Frontier Institute for Research and Sensor Technology. It's an interdisciplinary group with scientists from all over campus, physicists, chemists, electrical engineers, all working together to solve some really difficult problems. In this video, I really want to concentrate more on the undergraduate program, how we run those programs. We're going to go upstairs to some of our undergraduate labs. We'll take a look and kind of talk through how we manage the programs. So let's head upstairs and check it out. So welcome to the PTC KeepWhere Technologies lab. This is one of 4 endowed labs that we have in our department. Endowments mean have a little fun to help keep the lab up to date. A lot of people haven't heard of PTC KeepWhere. KeepWhere is a Maine-based company. They really spun out of our computer engineering program. If you think about industrial automation, where you have devices handing a product from one part of the manufacturing line to another, all these machines have to communicate with each other. KeepWhere built their business out of a software package that lets everybody's this piece of equipment talk to everybody else's that piece of equipment. They've expanded and now they're a part of a worldwide company. They hire a lot of our grads and they're particularly interested in our computer engineers, and so it's a good application or a good place where you can see what a computer engineer might end up doing. So there's a application where we need good software knowledge, but we also need to understand the hardware involved and how these devices communicate with each other, and it's a really good match with what we produce in a computer engineering program. Contrast that with a computer science program, a pure software degree, maybe not the hardware knowledge that they would need to succeed. An electrical engineering degree, in-depth hardware knowledge, not quite the software skills to produce devices like that. KeepWhere endowed this lab, and so they tend to, what we worked with them, they brought their office design teams down there, and we tried to encompass some of their atmosphere in a modern, high technology office in how we set up the furniture and the look and feel of this lab. You can get a little feel for how we run some of our courses in here. We'll start that in really kind of the computer engineering centered courses is what we tend to schedule in this lab. You can kind of look around and start to get an idea. We have monitors set up so students can come in and use monitors. We're out of the business of maintaining our own computer clusters. Every student brings in their own laptops. They come in and we try to give an environment where they can plug in, have a welcoming environment that's easy to talk through. Stand-up desks is really easy for us to wander up and down and see what students are working on, interact with them, and whether we're in a lecture setting in a course room or they're developing their own tools. So we run most of our computer engineering labs in this course. We run our computer architecture labs in here. You can see in the background we have some of our robotic arms that we'll set up. We'll pull those out and run the robotics courses in here. The one the only computers you do see in here, a lot of the students watching this video pick up on them, are these little guys down below here. So these are Raspberry Pis. They're convenient for us. They're a really popular platform. They're like $35 a piece, so they're inexpensive. but it turns out they're pretty powerful. You can network them. And for us, in a teaching environment, one of the nice things is the hard drive is just an SD card. So for a few bucks a student, we can pass out a setup that's exactly what we want to train the students in. If we're talking about automotive security and secure applications, every student can maintain their own small platform. We can hack into each other's machines. We don't have to worry about breaking anything. And we're not messing with students' laptops that way. So it's an easy way for them to boot up in exactly the environment we want to teach. Computer engineering, we think about, what we want you to think about in computer engineering isn't so much the large desktop computers you might program every day. We do those things. We have people who go to work at places like AMD, they go to NVIDIA and deal with those large computer architectures. But the vast majority of our program and the vast majority of our students are going to work in places where we're using little computers that get buried in devices you use every day, right? So computers inside your cell phone. If you're driving a car, you have 250 of these little devices. They all have to communicate with each other. They all have to share information. They're controlling your analog brakes. They're controlling your engine controls. They're controlling how much light comes off the rear view mirror as you're using it. And so it's the computer engineers that understand the hardware side, how to make those devices talk to each other, along with the software side, how to write good, reliable software that works every time. These little devices here are what the kind of thing you might see in like a Nest thermostat, something like that. So little networkable devices that the computer engineers would end up using. Very much a computer engineering emphasis in this lab. I think where we'll go next door is the Texas Instruments Analog Circuits Lab, where we do kind of the hardware side. So let's head that way. Welcome to the Texas Instruments Analog Circuits Lab. So this was actually the first of our endowed labs. It's funded by Texas Instruments. Texas Instruments maintains the main fab down in Portland, and a lot of years they're the single biggest dollar value exporter in the state of Maine. So they're kind of a big deal. When they moved into the state, they took an interest in our program. They actually set up one of our first endowed labs. I like bringing people into this lab. It gives me a good chance to talk about kind of the experience our students will go through as they go through our program. So in our program, this fall, I'm going to have somewhere between, say, 65 to 70 traditional first-year students coming in. And they'll be about equally split between electrical and computer engineering students. I'm going to take those 70 students and we put them in kind of a standard first-year seminar course. It'll be a one lecture room and an instructor in it. And we're trying to accomplish a lot in that class. We want everybody to understand who we are and meet us. We want them to know about campus services. How do you get a calculus tutor? How do you get lined up with a career center? How do you find the services that you need to be successful here on campus and be aware of all that? We're going to make you go over to our job fair first year. So every year we have an engineering job fair that happens in October. If you've seen videos of the campus rec center, there's 3 basketball courts next to each other. Engineering companies are going to fill that, and these are companies paying to come here and recruit our students. I want every first year student to get a resume together. They're going to work with the Career Center and have it reviewed. We want them to be able to walk up to somebody at the job fair and shake a hand and introduce themselves and say, hey, this looks like an interesting company. How do I get involved? So all of that is kind of going on in our first year seminar course. But that's a 1-credit course. We're going to also pull those 70 or so students, and I'm going to break them into 4 lab groups. And so any given afternoon in the fall, they're going to be in this lab, right? And they're going to be working on a project, and we're going to lead them through a project start to finish. And so in the past 3 or 4 years, the project has been a little board that we're putting together. Looks like this guy, right? And basically, this is funded by the Maine Space Grant Consortium, right? So this is a NASA-sponsored project. It has all sorts of things going on. There's a little computer, there's an accelerometer, a pressure sensor, a temperature sensor, and then we're going to plug on top of this board a second board that has an amateur radio transmitter. It's going to have a GPS on it, and basically when we're all done, they're going to have a device together that we can launch kind of anywhere in the world and track where it goes and what the environment is. It's an interesting project. It exposes people to areas that they're going to learn about as they go through the curriculum. So, first year they're putting one of these together and they're learning a lot of skills that we hope they're going to carry with them throughout their time here at UMaine. We're going to be, some of the work is pretty fine. We'll pull out the microscopes and teach everybody to surface mount soldering. There's a lot we're trying to accomplish in that first year lab. We want everybody, I'll get people coming into a program like this that have all sorts of different experiences. And some of them have been doing robotics clubs, some of them have been building things since they were 10 years old, and some have never touched a wire before. And that's all good, but we want everybody to get comfortable right off the bat getting their hands dirty. They're all going to learn to surface mount solder. They're all going to learn to kind of read a schematic and kind of figure out what's going on. When they solder it up and it doesn't work, we want them to have those debugging skills where they're able to measure things, figure out what's not working. It's actually a pretty complicated system once to get all of this stuff talking together. It's a challenge to get through this in a one semester course, but we're going to do it, right? We're trying to get a lot more going in that course as well, right? So at a lot of schools, you go in the first year, students are going off to calculus, they're going off to chemistry, and these are big classes. It's easy to get lost. We want every student to start developing that sense of community, right? Where I've got only 70 or so students, they're all going to know each other. We're going to make sure they learn, they meet each other and start working together early on. So in any given day, 15 or 20 of them are going to be in here. They'll be working with a partner, putting one of these projects together, right? I'm going to hire, probably in any given afternoon, I'll have 3 or 4 second-year students who have just been through the project come in and act as helpers, right? So I'll have an instructor, 3 or 4 second-year students, and what we're trying to build there is a little bit of mentorship. We want those second-year students to meet the first-year students. We want them to know each other. They're going to go through the program together as they go on through the program. So basically trying to get everybody comfortable building something, putting it together, using lab equipment, and getting their hands dirty right off the bat. Now I have 4 of these endowed labs here, and what that means is I have the ability and take advantage of it to keep students in a lab essentially every semester in this program, right? So first semester, you're going to be working through a 3-credit course, 1 afternoon a week, you're going to be building one of these. Next semester, you'll be in our first programming course. We're going to emphasize small processors that get embedded in all sorts of applications that are embedded, the automated thermostats or the analog brake controls or things like that. So we'll be doing our first programming course that way rather than going over to computer science and talking about some abstract software package. Third semester, we're going to be doing your first digital architecture design, so you'll be dealing with digital architectures. Fourth semester, more the analog circuits design. Then we're into electronics junior year. So basically every single semester you're in this program, you're going to be in a lab course, right? And I have freshman, sophomore, junior, senior labs set up and ready to go. I love lecturing. I go up there, I explain all sorts of stuff. If students can't build it, it's not so good. So that's kind of the goal as they work through our program. We said we're going to start off in this program with probably about 70 or so, 65, 70 first year traditional students. If we take a step and start talking about, well, how does that evolve over time? Typically I'm teaching a required junior level course, right? And so by junior year, that 60 or so, 65 or so incoming students is probably closer to about 40 students in my required course. And that's, again, combined electrical and computer engineering. So those 40 students that make it to junior year, by and large, are going to make it out the door, right? So they're going to be, that's the graduates that are going to come out as that community. For a required course, again, probably have 1 lecture section, we'll break those up into labs over 4 days. By the time I'm looking at junior labs, usually I've got 10 or 12 students in a given lab course. So that's about the size of the group that we're breaking out into to actually do these projects where we're building things. If we kind of go in more towards senior here, right? We mentioned all the different areas that an electrical engineer or computer engineer might be specializing in. Those 40 students start to sort themselves out into electives as they start to identify their careers. So everybody's going to pick, about a half a dozen courses that they're going to choose to specialize in that are geared to what they want their eventual careers to be. So it might be power engineering, it might be sensor science and development, it might be electronics design, it might be communication systems or digital signal processing and radars and sonars. As we start teaching those courses, you can imagine that a typical classroom size for a course like that might be a dozen students, right? So it's a pretty typical number for us in, say, the senior level electives. From my perspective as an instructor, that's kind of a magical size. It's really nice that I'm able to fill that many students and be able to present those courses and all those specialties. It's also really nice that with a dozen students, it's easy for me as an instructor to turn around and say, hey, this theory is really good. Let's go down to the lab that my graduate students are using and use the real equipment, right? And use the real tools that they have access to. Basically, it gives us students a chance for an experience here with that small class size that you could never offer in a larger classroom setting, right? I'm not going to get overwhelmed in my graduate lab by having a homework assignment where a dozen students come in and use the equipment. And it turns out that for me to recruit students into my graduate program, I kind of want to do that, right? We have all of the graduate programs here at UMaine. We go masters and PhDs in both electrical and computer engineering. But that said, our grad programs are pretty small. We don't draw from a lot of local industry. We rely on recruiting right out of our undergrad courses. So anything I can do to interest students in what I'm doing in a graduate program is a good thing. So I'm going to involve undergrads in the grad program as much as I can. We do a couple $1 million of research a year out of this department. It's funded research. We hire a lot of our undergrads to work in that research because that's where we get our best graduate students, almost always. So that's kind of the overview, the track from first year student through senior year. We're going to keep your hands dirty every single semester. We're going to try to give you options for where you can specialize in your program. And hopefully along the way, we're going to expose you to a lot of research experiences that might be hard to pick up in a larger school. I'm going to know every student that comes out of this program, right? I interview every single one that comes out. We always talk about, okay, job placements and how you're doing and what do we do right and what do we do wrong. I think we do an outstanding job at giving students a good experience for students that come through a lot of different backgrounds. So for me as a faculty member, right, our total undergraduate population, we've got just over 200 students in this program, right, in all 4 years. Almost a magical size. It's a big enough population we can offer all the specialties. It's small enough that I can get away with doing things that I can't do in a larger program. Going to keep your hands dirty the whole time. Junior year, you're going to define your own senior project. So in a lot of larger programs, you might have an instructor come in and say, for senior project this year, we're going to split up into 6 groups, and each group is going to have a dozen people in it, and you're going to design this device, right? It's not how it's going to work here at UMaine. You're going to get together with a partner and you're going to find a device that you're interested in building, right? And it might be coupled with an internship you had. And we're going to, you negotiate with us until we define a good senior project that we know you can succeed in. Once you have that proposal down, you're going to build it, right? And you got to make it work. You got to meet a specification in order to graduate. It's a very real experience. It's one that our students really appreciate. Job placements are great in this major. In the state of Maine, we have about 2.8 job advertisements for every graduate in the state in electrical or computer engineering. Last year, I had over 70 companies in our job fair trying to recruit electrical or computer engineering graduates. I had about 35 grads, right? And so job placement has been great, and it's been great for as long as I can remember, right? Usually if the job market is really good, my placement rate when I interview them before they graduate is, say, 85%, right? And then the reason is because I'll have students that are saying, yeah, I'm gonna go hike the Appalachian Trail, right? If job offers are tight in a given year, and if I think back to 2009 when the economy was not that great, our job placement rate was 100%. And the reason was every single student who could find a job took it and jumped into that job, right? So jobs are there. It's a very high demand, both in the electrical and computer engineering areas. This is the Allison Whitney electronics lab. So in contrast to the two labs that we just saw, the KeepWhere lab and the Texas Instrument lab, this one and the one next to us are endowed through alumni support, right? And so Al Whitney was a faculty member here for many, many years and with an electronics background. And so this endowment supports this lab. We run a lot of the upper level electronics labs in here. So similar to the TI lab, kind of a hardware emphasis in here. You start to get a little flavor. If you contrast this with the TI lab, where we'll have lab groups of say 15 to 20 students, the early labs, a nice setting for doing that work. Usually we're junior, senior level by the time we get into this lab, and so you can kind of get a feel. We have these middle lab stations. I think we have about a dozen seats in here, so that's the largest lab that we'll have, junior, senior year. The labs are set up with some basic test equipment, a monitor. Students will also have their own portable scopes that they'll be debugging with by the time we get to junior year. So they'll be able to use lab equipment either here or at home. The labs are actually physically a lot bigger than that. We have some tables set off to the side. We'll have senior projects going off to the side. And we'll have students coming in here even while there's a scheduled lab going on that are working on their own projects. They're working on senior projects, and actually we don't care what they're working on. If they're tearing their own computer apart, that's fine, that's invited. We try to keep these labs accessible all day long. There's probably a formal lab going on in here every afternoon. But a student who comes in to work, and whether it's working on homework or working on building something, that's okay. We'll have access to parts cabinets and ways for them to kind of do useful things. I mentioned here earlier, a lot of classes are likely to give assignments that involve some lab work that even though they don't necessarily have a formal scheduled lab. And so those students are free to come into spaces like this and work anytime during the day, not just in the afternoons when there's a formal lab schedule. So TI lab, I think we try to cycle equipment, or this is the Whitney lab, sorry. We try to cycle equipment through here probably 4-year rotation or so. So the equipment is fairly modern, fairly effective lab space. So this is the computer architecture lab, and we use, again, the setup in here is kind of a combined class and lab space. The biggest thing we have that makes this a lab are these interfaces that we're able to connect to a lot of small processors. So when we teach our first programming course in here, students are going to have their own little development boards, and I don't have one of those set up here, but they'll be plugging into the hardware that lets us interact with them, lets them work with their laptop to develop programs on these small devices that get embedded in everything that you use anymore, right, that has a computer in it, right? If you're using your microwave oven, there's some computer watching what you're doing as you're running that thing. So we run our first software class in here. We run our first hardware design courses in here. And again, kind of the idea is, as we're describing things, as we're going through how things work, we want students to be putting it into practice. And so that's the theme at this school. That's the way we like to run our programs. We'll bring in groups to do all sorts of specialized projects in this lab. So the computer architecture lab is one of the great endowed labs in this program. We have a series of smaller labs spread out throughout. They're more research oriented, but for the upper level courses, we'll be doing our senior project space. We'll be sneaking our students in there as well. So these are kind of the formal lab spaces. I just want to thank everybody for coming on this tour with me. I hope you found it informative. You should feel free to contact me at any time. My name is Don Hummels, Electrical and Computer Engineering. So if you have questions about the program, reach out to me. I'll be sure to get back, and I look forward to meeting you in the fall. It's a great place to spend 4 years. We have a great environment here at the University of Maine. It's a safe environment. We're surrounded by beautiful forests. We have a fantastic rec center. Students have a great experience here.